linear regression, and the last test that you guys need to know how to run is a linear regression test, and also there's a linear regression interval. But before we get into that, what we're going to do is just kind of go through some quick review. So if you'll take a minute, that first page of your packet, you can see this study on drinking and blood alcohol level. The volunteers at Ohio State. Uh, Go ahead and plot the data of number of drinks and then the blood alcohol level into your calculator, and we'll just go through a quick reminder on how to do all of that. So if you want to pause this for a second to go ahead and put it in, I'm going to go ahead and have it going in my calculator already. So as you can see, I've already got all the data in my calculator on the blood alcohol levels and number of drinks. So the first thing we're asked to do is to describe the or comment on the relationship, which means we need to create a scatter plot. So again, to do that, you're going to hit second y equals. We'll turn our plots on. So make sure it's a scatter plot. And then you've got x list 1 and y list 2. Remember, we're not putting student number into this. It has nothing to do with it. We're plotting the number of drinks versus their blood alcohol level. I would encourage you look at y equals real quick, make sure there's nothing here, no other plots turned on, and zoom number 9, zoom stat. That'll get us a good look at this. So this looks like we have a strong linear and positive relationship. Remember, that's how you describe. So the strength, the direction, and whether it's linear or not. Thanks for that. No, go away. Okay. So then now we want to describe it mathematically. So that's just where we go and we create the line of best fit. Remember when we do linear regression in here, we pick number 8. So linreg number 8. X list, Y list, we don't have any frequency lists. You can store the regression in Y1 if you want, so you can see what it looks like. But there's what we want right there. So it's negative 0.013. So y hat equals negative 0.013 plus, we'll go 0.018x. You might remember we also would do this stuff as you could do BAC equals 0.013 plus 0.018 times number of drinks. If you want to put your context right in there. So take a moment and see if you recall. Again, go ahead and pause it if you'd like. But interpreting the slope and the y-intercept, interpret the correlation and the coefficient of determination. So I don't know if I'm going to have enough room to do all this right here, but we're surely going to give it a shot. So take a moment real quick, see if you can come up with those on your own, and then unpause the video and you can fill them in with me. So the slope, all right? Remember that's for each additional drink. We'll go with consumed. Now this is the big one. Remember the predicted BAC increases by 0.018. Y-intercept, remember that's where when at 0 drinks, the predicted BAC is 0.013. I don't think that that really has a practical meaning because how could you have a blood alcohol content if you hadn't had a drink? Correlation, remember that's R. So R equals 0.89, and that basically confirms what we already know. It tells us it's a positive and pretty strong relationship because we're close to 1. The coefficient of determination, remember, is R squared. Um, so that's the one where we say, let me take a look at what it was real quick. So we'll call it 80%. Remember, 80% of variation in BAC can be explained by the linear model of number of drinks. All right. And then one other thing that we remember we can go back and do is create a residual plot. So in order to do that, remember we're going to go back and we're going to create a scatter plot. But this time, instead of list 1 versus list 2, remember, so if you scroll down, you can actually change this. If you hit second list, every time you run a line of best fit, you'll have this residual list. So this only works if you've actually run the line of best fit. So if you haven't run the line of best fit already, this will not work. But now if we hit zoom 9 again, we get a good look at the residual plot. And based on that residual plot, remember, there's no pattern to this. So that tells us, is a linear model appropriate? Linear model is appropriate because there's no pattern. Because there's no pattern in the residual. All right.